and we have just solved the equation. If you don't know how to factorize, please use formula method, unless there is a restriction. So the quadratic formula says if ax squared plus bx plus c is equal to 0, then x is equal to what? Negative b plus or minus root b squared
minus 4ac over 2a.
I'm going to ask you someday to prove this for me. Okay? Does this make sense, everyone? All right. So before we do our investigation, can I ask you to try FF in each case? Or maybe just let's do the easy one. Then you can deal with others later. BB in each case. Okay? BB in each case quickly. Then I'm going to go around and give you a note on quadratic function. Once you are done with the BB in each case, you stick that into your note. You go to Edmodo. You start your investigation. You can leave space to write this later, my young lady. When I give you work to do in class, you try to do the work in class. The idea is so that you can share knowledge among yourselves. Oh. Okay, so you can leave space to write it. So you solve it together first. Miss, what are you doing? What are you doing? Oh, okay. I thought you were writing. I'm like, okay, that space is not enough for everything. You leave enough space for 1 and 2. Even this. Have you written all this? Does everybody have a paper yet? Yes. Let's go to the laptop. Okay, sorry. You can take that. We don't need to do that. There you go. So everybody got a paper. That will be the last thing I will explain. So quickly, please, 5 minutes. You should be able to finish that in 5 minutes. Then I want to explain something about the graph of quadratic function, and I'll leave the rest to you. 5 minutes, please. So you should write this note later, young man. So where do you write the note then? Where's the space for the note? No pick and choose in the class. Everything I write, you must write. Okay. You write it later, but no. We're going to do the quadratic function also. Quickly. I can use my set if you want. One B and 2B. Just a refresher exercise. Okay, just so you to like remember what you've done before. And the rest are there in your textbook. I'll tell you where to find it in both books. In the HL book, this is chapter 14 of the book 1. In SL book, you can find it in book 2, I think chapter 2. So it's in the book 2 of SL book, but book 1 of the HL book. Okay? So please look for this. This is the first section, A, not B. Solve all the other questions on your own, especially if you are not so familiar with quadratic, or you haven't really done enough in the past. Use that opportunity, please. Hi, Miss Kadina. Three more minutes. Of course, you don't have to do it both ways. You can use any of the two arguments in number 1. So I don't expect you to use both arguments. Let's take 2 to 3 more minutes, please. solve any. That was why I first transferred. Was it Ryan that told me to move to the other side? I think it was an need to do that first. You only apply your look. You only apply your quadratic formula from this step. So you have to first do the same thing up to this point. But so instead of this, you can apply the quadratic formula.
They're both the same. The two answers are they're both the same.
The two answers are the same. What do you mean?
For B.
For B, oh, okay. So you have what kind of roots is that?
Huh?
What kind of root is that? The quadratic equation has what type of root? We'll talk about that later.
Wait,
you don't know.
Discriminant thing?
No.
Oh,
sorry. Equal roots.
Oh, right, yeah.
Is to have equal complex rows or distinct roots. So discriminant is what we use to investigate that. We'll talk about that after the. It's part of the chapter. Yes, exactly. So when the graph is coming down, and this is the line, the graph goes like it touches it and just go back. Touches at one point. Okay. So I'm going to quickly go into this. So I've printed this particular note. That's the one on the paper. So I'm just going to quickly explain. Everybody please listen. This shape is a parabola. Okay? This shape is a parabola. And that is the graph of a quadratic function. So it could go this way or it could come this way. Understand? This turning point is the vertex. Just like the vertex of a shape. Remember, we call this vertex in a shape, right? This turning point is the vertex. So it's a point. It contains x, y. Okay? The next thing is the minimum and the maximum. So if in this case, it opens upward. You see, it opens at the upward like this. If it was the other way, it's going to open downward. If it opens upward, then you say the vertex is the minimum or the minimum point. You don't need to say minimum turning point. You can just say minimum point. All right? Or the minimum. So the minimum point is here, and the y value is the minimum value. But what it means is that y can attain every value here, right? Are you with me? Y can attain every value here. But y cannot go to this point, right? So this is the least value y can attain. So when it is minimum value, we talk about the y value only. But minimum point is the x, y together. That is, there's an x coordinate, right? That is corresponding to that y coordinate. Does that make sense? So if it is maximum, the other way, it will go this way and turns at the top. Then you have a maximum, and that is the next point here. You see, every parabola has a line of symmetry. This is the reason I asked you to use symmetry and not reflection and not symmetry in yesterday's activity. Because we saw that some graphs have the cross beyond the mirror line. So when you are using a symmetry, the language symmetry, as far as I'm concerned, you want to talk about one particular shape that can be divided. Not when 2 or 3 shapes are together. Am I making sense? You only say a shape is asymmetrical or that picture is symmetrical. Is that not? Not when you are trying to investigate the relationship between 2 things on a paper. Then I don't think symmetry is the right language, especially with the construct. Am I making sense? So you rather say, oh, it's a reflection in yesterday. But here we can say symmetry. This shape is always symmetric. And the line of symmetry, or the axis of symmetry, is that line that divides into 2 equal parts. That line always passes through the vertex. Always passes through the vertex. Does that make sense? I think that is what I've said here. Now, the value of y, where it crosses the x-axis, the value of y where it crosses the y-axis is the y-intercept. I think we know this even from rational function. We always talk about y-intercept, y-intercept. So this is our y-intercept. This x-intercept are used to find the roots. Okay, we'll talk more about that also later, but I think you are familiar with this also. So x-intercept is where it crosses the x-axis, y-intercept is where it crosses the y-axis. Any questions? So this is all about the paper that I've given you. I actually got it from here as well. So rather than copying, just stick that into your notes and go to Edmodo, start your investigation. That's all about quadratic for today. See you next week. Can you turn that off?